Hi everyone. This is the first class for binomial expansion. Um, Before we start, I would like to tell you why binomial expansion. Yeah, if you have like 2x plus 4 raised to power 1, you already know that any value raised to power 1 is the same as the value. So 2x plus 4 raised to the power 1 is the same as 2x plus 4. But if the power is 2, usually we say 2x plus 4 multiplied by 2x plus 4. Why? Because 3 squared means 3 times 3. 8 squared means 8 times 8. So the bracket square means the bracket times the bracket. But when multiplying bracket, we don't write the multiplication sign. We choose to not write anything between the bracket. Yes. So this is very common right from the beginning of mathematics. This is what to do. So even if the power is 3, we just add another. Yeah, the higher the power, the more time it takes. But come to think of it, the power is 5. Yeah, the power is 7, the power is 20. So that one is so tedious, so boring. So it's like doing a lot of work a day. The boring is too much. So the reason we have binomial expansion specifically as a topic. Okay, so now let's see how we expand 2x plus 4 to the power 5 using binomial theorem using Pascal's triangle. Okay, so to start with, using the binomial theorem. Okay, so we have 2x plus 4 to the power 5. Let us pay attention. If you have 2x plus 4 to the power 2, when you expand this, 2x squared is 4x squared. 4 squared is 16. 2 times 2x is 4x. 4x times 4 is 16x. How many times do we see? 1, 2, 3 times. What is the power? 2. That is the first point of observation you need to note, that whatsoever power you are given plus 1 will give you the number of times. So definitely this one is going to give us how many times? It is going to give us 6 times from the basic things that we have been doing. Okay. So we want to expand this using the binomial theorem. This one starts, this one ends. But this one here, what happens to this? This one decreases in power. This one increases in power. You can see the arrow, I put it down to tell you that this one decreases in power, this one increases in power. So what do? We say 2x, the power given is 5. How many times I said we are going to have? We are going to have 6 terms, plus we are going to get a term here, plus a term here, a term here, a term here. 1, 2, 3, 4, 5, 6. Just because of the starting, I just want to read this way. This one starts, this one ends. 4 to the power 5. This one starts, do not forget, 2x to the power 5. So what happens to this? This one will end the process, 4 to the power 5. I hope it is clear. This one decreases in power, this one increases in power. So what do we do next? We say 5 combination 1. This is supposed to take 5 combination 0, but it will not change this value because 5 combination 0 is just 1. 1 times this is just this one. So some teachers, they start with this one combination 0. But I usually say I usually start from the 1 because this one, writing it here is like a waste of time. This one starts with this power. This one ends with this power. This one decreases in power. This one increases in power. So 5 combination 1. So what is next? You write 2x. You write 4. Is that clear? 5 combination 2. What is next? 2x. And then what? 4. I'm not done yet, just for you to understand the sequence. 5 combination 3, 2x, here is 4. 5 combination 4, 2x, and here is 4. This one starts, you can see it, 2x to the power 5. This one ends, 4 to the power 5. You don't need to do it as I'm doing it. I write this, bracket plus bracket plus. No. You don't have to read that one. And because of I'm just explaining. But just note that the power is 5. We are going to have 6 terms. 1, 2, 3, 4, 5, 6 terms. So now I said this one decreases in power. So if this one is decreases in power, 2x, it starts with power 5. Look at 2x, power 4, 2x, power 3, 2x, power 2, 2x, power 1. So easy. Yeah, maybe it's time consuming, but you can understand it. This one increases in power. Here it appears for the first time. 1, 2, 3, 4, 5. See, this one decreases. 2x5, 2x4, 2x3, 2x2, 2x1. Then this one what? Increases in power. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5. So easy. Okay. Now what is next? 2 to the power 5 is 32. Then x to the power 5. What is 5 combination 1? It depends if your teacher has taught you permutation and combination. Of course, we are dealing with permutation and combination. There is a series of the permutation and combination. I think I've gone to lesson 7 or 8 before this. But unfortunately, I haven't started solving permutation and combination. I'm still dealing with factorials. But the calculator can do it for you. Yeah. So what you do is you enter 5. You enter 5. Ask your teacher or your seniors to tell you the button for the combination. According to the one I'm using here, it is here, NCR, that is N combination R, NPR, N permutation R. But because I need combination, I've written on the 5. According to the one I'm using here, the color is yellow, so I press shift. You can see the C comes, and I press 1. What do you see? You see 5. So therefore, 5 combination 1 is 5. 2 to the power 4 is 16. Then we have x to the power 4. You have utilized the power 4. Do not write it outside again. 4 to the power 1 is 4. 5 combination 2. We go again. It is the template is already in your calculator. Yeah, so just remove the 1 and write the 2. What do we get? We get 10. 5 combination 2 is 10. Then 2 to the power 3 is 8. X to the power 3. 4 to the power 2 is 16. 5 combination 3, the same thing again. For beginners, you can remove the 2 and enter 3. What do we get? We get 10 again. Don't worry, I will explain why it keeps giving the same. We have 10. 2 to the power 2 is 4. X squared. 4 to the power 3 is 64. 4 times 4 is 16. 16 times 4 is 64. Then 5 combination 4. Oh, I'm sorry. 5 combination 4. What do we see? We see 5. 5 combination 4 is 5. 2 to the power 1 is 2. X to the power 1 is x. 4 to the power 4. is 4 times 4, 16. 16 times 4, 64. 16 times 4 is 256. 16 times 4, 128, 128, 256. So 4 to the power 5, 4 to the power 5 is 256 times 4. 4 to the power 4, oh no, not power 4, power 5 is 1024. Is 1024. But suppose you think that at the moment you don't have a scientific calculator, but you want to know why 5 combination 1 is 5. Well, the formula is here. N combination R is n factorial over n minus R factorial R factorial. That is where I will have to go to after the factorials. This is the formula for n combination R. So if you have 5 combination 1, it will give you this n is here, 5 factorial, then n minus R, this minus this minus this. 5 minus 1 is 4 factorial, then R, this one here, 1 factorial. So 5 factorial over this one will give you 1. Will give you 1. Okay, well, because of the time, then we shall get to that. So this is 32 x to the power 5. 5 times 16 is 80. X to the power 4. Oh, sorry, there is 4 here. 5 times 16 is 80. 80 times 4, 320 x power 4. Yeah. 8 times 16. 8 times 16. What do we get? 8 times 16. 8, 128. So 1280 x cube. Yeah. 4 times 64 is 256. So 2560 with this 10. Then x squared. Yeah, 5 times 2 is 10. 10 times 256. 2560 x plus 1024. So this is what we have if we expand this one using the binomial theorem. So 1, 2, 3, 4, 5, 6. So I hope we get it. Let me write it down here. 3 to x power 5, 320 x power 4 plus 1280 x cubed plus 2560 x squared plus 2560 x plus 1024. So now let us come and solve it using using Pascal's triangle. For Pascal triangle, if you have 2x plus 4, 2x plus 4, 2x plus 4, 2x plus 4. I want to give you first the triangle 2x plus 4. This is 0, 1, 2, 3, 4. 2x plus 4 power 5. Okay. When the power is 0, remember from laws of indices, any value raised to power 0 is 1. Yeah. So if the power is 1, you write here 1, you write here 1. Yes. The power is 2. 1 plus 1 is 2. Write it at the mid part, then you write this one. So this is 0, this is 1, this is 2. Now we go to 3. 1 plus 2 is 3. 2 plus 1 is 3. Write it between them. So this is 1, this one. You can see the triangle is moving. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 here, 1 here. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1 here, 1 here. Power 0, power 1, 2, power 3, power 4, power 5. The good thing is that power 0 starts with 1. Power 1 starts with 1 again. Then you can see 1. Power 1 starts with 1. Power 2, every number starts with 1. But the one with power 2, you will see 2. The one with power 3, 3 starts. Power 4, 4 here. Power 5, 5 here. Inevitably, everyone starts with 1, ends with 1. So if we want to deal with an expansion with a power of 5, these are the ones we use. 1, 5, 10, 10, 5, 1. Okay. So for binomial theorem, Pascal's triangle. Pascal's triangle. We say 2x plus 4 to the power 5. What are the coefficients? 1, 5, 10, 10, 5, 1. 1, 2, 3, 4, 5, 6. See, 6 terms. So now we go. We have 2x here, but because of this is 1, we don't consider it. So let's just say 2x power 5 plus what is next is 5. We say 2x. We say 4. The next is 10. We say 2x. We say 4. The next is 10. We say 2x. We say 4. The next is 5. 2x, 4. The next is 1. We take only 4. This one starts with a power of 5. This one ends with a power of 5. Something similar. The only difference is the coefficients. This one decreases in power. This one increases in power. So if this one is decreasing in power, power 5, 2x power 4, 2x power 3, 2x power 2, 2x power 1. If this one is increasing in power, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5. So 2 to the power 5 is, the rest is just the same. 2 to the power 5 is 32, x to the power 5. This is 5. 2 to the power 4, 16, x. 4 to the power 1 is just 4. This is 10. 2 to the power 3 is 8, x cubed. 4 to the power 2 is 16. This is 10. 2 to the power 2 is 4, x squared. 4 to the power 3 is 64. This is 5. 2x to the power 1 is the same as 2x. 4 to the power 4 is 128. Yeah, 4 times 4 is 16. 16 times 4 is 64. 128. So 4 to the power 5 is 256. 64. Oh, this is not 128. Sorry, so yeah, this is already 10. 4 to the power 5 is 1024. Yeah, I'm rushing for the time. I don't want to go. Oh, okay. It's 256. 256. Okay. So here is already 32x to the power 5. 5 times 4 is 20. 20 times 16 is 320x. Power 4. Oh, sorry. 4 to the power 2 to the power 4 is 16. X to the power 4. So x to the power 4. 5 times 4 is 20 times 16 is this. 8 times 16 is 128. Yeah, 128 times this. 1280 x cubed. 4 times 64 is 256 times 10, 2560 x squared. 5 times 2 is 10 times 256, 2560 with this x plus 10, 24. So when we compare Pascal's triangle binomial theorem, we have the same. The subsequent videos, I will not join them. I'll be doing a video for binomial theorem and for Pascal triangle, so we don't have much time in a video. Thank you for watching. Do not forget to follow, like, share, and comment. See my next video. And don't forget to subscribe to the YouTube channel.